And last time we discussed, so if there is bromine, we are going to start the numbering which give lower number to the carbon atom bearing the bromine. That's what we discussed. Okay. So, but if there is a double bond and if there is a bromine, then you need to think. So I hope I'm audible. Jesleen and Zainab, good evening.
Yes, sir, you're audible.
Yeah, I just started discussing with Avyas and Ibrahim the questions, the theory part which we gave. So I gave you this assignment. Okay. So this sixth one, in the sixth one, actually, suppose if I ask that what is the name of this compound? So you are going to do the numbering from one end to another end. Got it? And so are you going to start the numbering from the bromine or the double bond? I'm asking about this one, sixth. Are you going to start the numbering from the carbon atom which is connected to Br? Will you do that from this side? Just a second. Or from the double bond side? Tell me. Any idea?
So from the double bonds.
Yeah, double bond is given more priority. Got it? So 1, 2, 3. Okay. Yeah. So this is 2-methyl prop 1. Okay. Double bond and triple bond are given higher priority over the bromine or any methyl or ethyl. You can write that point. This is from your NCRT only in-text problem. That's why it is very important. And what about the fifth one? Fifth one, if I do this 1, 2, 3, and 4, or I can do this 1, 2, 3, 4. So which number ring should I choose? The upper one or the lower one? I hope everybody is getting what I'm trying to ask.
Yes, sir. Yes, sir.
Wesley and Janam. So double bond is starting from the second position. Either you do the numbering from in the upper way or in the lower way. That is same. Are you getting my point? Then I should try to look at the bromine. So bromine is also getting a lower number. For double bond, it is starting point is 2. Here, from here the double bond is starting, and from here the double bond is starting if I start from CS3. So but if the double bond is getting the same number from both the sides, then I should do the numbering from the side which give lower number to the bromine. Got it? So this is correct. This is known as lowest locant rule. Got it? So any doubts in this, I hope you will be able to do it. Hydrocarbon C5 ester does not react with chlorine in the dark, but it gives a single monochloro derivative in bright sunlight. Why it doesn't react in the dark?
Sir, I think the answer for this is it's cyclopentane. Yeah. It's cyclopentane. Yeah.
Cyclopentane. Yes. How you identified it?
Because C5H10, so it can either be an alkane or a cyclic hydrocarbon, cycloalkane. but
Yeah.
it does not react with chlorine in the dark, so it cannot be an alkene. So it's a cyclo, and it gives only one monochloro derivative. So that's
Yes, that is the key point. So C5H2N plus 2, Jaslene and Zainab. 2N plus 2 is how much? 5 into 2 is 10 plus 2, 12. Got it? This is alkane, but this is C5H10. So C5H10, either it could be an alkene with a double bond, or Zainab, it could be a cyclic compound. Is it clear to everyone?
Yes, sir.
But if it is an alkene, then it will have lot of different types of carbon atom. The one of the double bond, another next to double bond. Got it? It will have different types of carbon atoms. So it is not going to give only one monochloro derivative. One monochloro derivative means, as Ibrahim said very correctly, that it is symmetrical. It should be symmetrical. It should be cyclic. And Abhyas, tell me why it is going to give only one monochloro derivative if I put the Cl. There are 5 carbon atoms. Abhyas, am I audible? Zainab, tell me why it is giving only one monochloro derivative. Why? Justine, tell me why. Abhyas, Zainab, am I audible to all of you?
yes, sir. Yes, sir.
Yeah, it is a symmetrical molecule. Okay, all sides are same. Got it? You can rotate it in any way. All 5 carbons are same. So wherever you put the chlorine, it is one chlorocyclopentane. If I put it here, I'm not going to count the numbering from this carbon. I'm going to do the numbering directly from, this is wrong, okay? So I'm going to start the numbering directly from the carbon atom where the Cl is being attached. So one chlorocyclopentane. Got it? So this is cyclopentane because it is symmetrical. And how I got the idea, CnH2n can either be, if there are 2 hydrogen less than that of alkene, it can either be a double bond or it could be a cyclic compound. How cyclic compound? Because I need to, suppose if I'm making a ring, so in order to join the ring, I need to remove the 2 hydrogens from an alkane. So whatever the valency is free, that will connect and that will form a cyclic compound. Okay. So that's why this is a cyclopentane, and that one is chlorocyclopentane. Got it? This we already did in the last class, and but the reagent you need to select appropriately. Avyas, Zainab, Jasleen, Ibrahim, tell me quickly, which is going to be the right answer?
A Cl2 slash UV light. The first
Yeah,
one.
UV light. UV light is has,
More energy than normal.
yeah. Actually, it has enough energy. Yeah, got it. So Avyas, I'm audible. This is not going to work. This dark doesn't have energy. Okay, doesn't have that energy, so this is the right option. Which is an example of, what is this VIC? What does this mean?
Sir,
Yeah, vicinal, exactly. So Avyas and Jasleen, vicinal means in the vicinity. Got it? So 2 same type of groups on the adjacent atom. Yes, Avyas, am I audible?
Yes, sir.
Okay. So are you getting any doubt? You can just stop me anytime, okay? Right?
Okay, sir. I have doubt in this questions.
Which one?
In the third question.
In the third question, actually, you are putting a chlorine atom. Got it? And because you are putting a chlorine atom, so you need to take Cl2, okay, because from where the chlorine is going to come. But you need to provide light to break the bonds. Then only the reaction can happen. Is it clear or not? Light, which
Yes, sir.
light? Sunlight or UV light? UV light is very energetic and that will break the bond between the chlorine atoms and that will help the reaction to proceed. So this is the first option which we should mark as the answer. The reaction is not going to happen in the dark. You need chlorine, and either you can write it like this also, HNU, which indicate lights for live photon of light. Got it?
Yes, sir. I got it.
Vicinal. Vicinal means two same group on the adjacent carbons. So vicinal dihalide or dichloride or dibromide. Okay. So this is 1,2-dichloroethane. Okay, that is vicinal dichloride. Dichloromethane is what type of dihalide? Can anyone tell me? Is it a vicinal? Is it a vicinal?
Yes, sir. It's a viscera.
No, means two same group on the adjacent carbon atoms. That is vicinal. So two same chlorine
So
atoms.
it won't be vicinal because there's no adjacent carbon here. So it
Yeah,
won't be
there is.
possible for this molecule.
Yes, exactly. There is no adjacent carbon. Got it, Abhyas? And Ibrahim, so this is what type of dihalide? Can you tell me? What type of dihalide is it? It is not vicinal. Vicinal short form is written as VIC. It is gem. The short form is gem and the complete name is geminal. Geminal means two chlorine on the same atom. Got it? So this is
Yes, sir.
geminal. Got it? So this is geminal and alkylidine chloride, ethylidine. Ethylidine is, this is the common name. Ethylene and ethylidine. Common name for vicinal and gem. This is from your NCERT only, okay? So this is, if you write alkylidine or ethylidine, it is actually the common name for gem, geminal. Gem means same atoms on same carbon. And ethylene dichloride, this is the common name. Is vicinal. If you have alkylene, it is vicinal. If you have alkylidine means I'm talking in a general way. Alkyl is you are going to put the number of carbon atom. Okay, ethylidine, propylidine. Okay, if it is alkylidine, it is basically gem. If it is alkylene, ethylene, that is vicinal. These are the common names. Gem and vicinal. Allyl is what? Allyl is means next to double bond. Carbon atom next to double bond is allyl. So this is allylic chloride. Got it? I'm not putting the H. I hope this is clear to all of you. Just let me know if there is any doubt.
Yes, sir. It's clear.
Okay. And the position of bromine in the compound. What should be the answer? I need to make sure that this carbon is having 4 bonds. Got it? So this is for one. So this is what type of carbon it is. Now can you choose the answers?
So it's allylic, yeah? Is it
Yeah,
allylic?
it is the carbon next to double bond. Allylic, yes.
Yeah.
Is it a secondary also?
No.
No, it's not second, it's tertiary.
It's tertiary, correct.
Yes.
Okay. And what is this known as if you are having the halide on the double bond, doubly bonded carbon? This is,
How is it tertiary?
no, this is vinyl. Vinyl is doubly bonded carbon is vinyl. Carbon atom next to double bond is allyl. Got it? Primary, secondary, tertiary is related to whether the carbon is connected to one carbon, two carbon, or three carbon. This is vinylic. Got it? So this is not tertiary. This is tertiary, this one. Because the carbon atom carrying the bromine is connected to three other carbon atoms. Got it? Zainab, is it clear?
Yes.
So tertiary. And if you have a doubly bonded carbon, that is called vinylic carbon. Okay. So I will give you one example and that will clear all your points. You can just write it. Okay. And I will include all of them. Just write it in your notebook and you will, all your doubts will be clear related to the naming. Suppose if you have this, so this is what, geminal or vicinal?
So it is vicinal.
Vicinal, in the vicinity. This is two same group on the same carbon atom. Geminal.
So it is nine.
Got it? Abhyas Ibrahim, is it clear?
Yes, sir.
Yes, sir. It's clear.
What type of iodo compound is this? Is it vinylic or allylic? Is it primary or secondary or tertiary?
So it's secondary.
Yeah, it's secondary because the carbon atom carrying the iodine is connected to two other carbon atoms, so it is secondary. Okay. Is it vinylic or allylic?
Allylic.
Allylic.
Allylic because it is, yes, Zainab, because it is connected, Jesslyn, it is connected to the carbon atom next to double bond. Okay, so this is allylic also and secondary. So secondary allylic. Got it. And what about this fluoride? Fluoro. What type of fluoro is this? Is it vinylic or allylic?
It's
Vinyl.
vinyl.
Vinylic. Carbon, because it is connected to doubly bonded carbon, which is known as vinylic carbon. Okay, so this is very, very important. And if you know this, believe me that lot of students preparing for JEE come to know this classification because this is so simple, they skip it. Okay, and they make lot of mistakes. So it's good that you people answered it really well. Okay, just one more I will get, and that you can easily figure out. This we have seen in the last class. So what type of chloride is this? Is it aryl halide or alkyl halide?
Sir, it's
Is it
allied.
it is aryl or alkyl halide?
It's allied.
Yeah, it is directly connected to the benzene. If it is directly connected to the benzene, that is aryl. Because the bromine is directly connected to the benzene phenyl. This is not, this Cl is there, benzene is also there, but the Cl is not directly linked to benzene. Okay, it is linked to the carbon atom outside, just outside benzene. So what is the carbon atom just outside benzene is known as, there is also a specific name. That is just like allyl. This is benzyl. This is benzylic chloride. And this carbon is also tertiary carbon because it is connected to 3 carbon atoms. So it is tertiary as well as benzylic. Believe me, if you write these 2 examples and the classification, lot of your problems will be simplified. Okay. In the subsequent organic chemistry chapters. Got it? Any doubts in this? Shall we move ahead? I hope it is clear. Avyaz, Ibrahim, Jasleen and Zainab.
Yes, sir. Clear.
Yes, sir.
Okay. So let's move on to.
So
Let's move
second,
on.
I'm still writing.
Yeah. Okay, great. Just write it. The classification. So benzylic is just will have benzylic alcohol in every chapter. It is going to come next to benzene is benzylic. Okay. So next we will move on to the preparation of alkyl halide.
Done, sir.
Okay. Preparation of alkyl halide from alcohols. Let's move on to preparation from alcohols. Just one more thing we need to do today. Yesterday we have seen that on the double bond you can add HX and the H plus is going to attach itself to the carbon atom which is already having more hydrogens. So Rich gets it. That was a mnemonic to learn. Where the for H plus. So where the H plus is going to come in. So it is going to attach itself to the carbon atom bearing more hydrogens. Got it? On the next carbon atom adjacent, you are going to put the halogen. This is Markovnikov rule. Rich gets it. So you are going to put the bromine on. Bromine is not hydrogen. So we are going to put it on the carbon atom which has less hydrogen. Hydrogen you are going to put on the carbon atom which has more hydrogens. That's what we discussed. Okay, that was Markovnikov rule. But there is an important statement that you should remember. And this rule is only for HBr. Only HBr means neither HF, neither HCl, neither HBr, HI. It is only HBr can add in reverse manner also. Can add on to alkene in reverse manner also. Reverse manner means what? In anti-Markovnikov way. Only HBr. This facility is there only for HBr. So HBr can add on to the double bond in anti-Markovnikov fashion. And when it happens in the presence of peroxide, in the presence of peroxide, either it will be written like this, peroxide, this is hydrogen peroxide, or peroxide has that OO linkage, or they will give it to you like this, or they will give it to you like this. This is benzoyl peroxide. These are examples of peroxide. Got it? Is that clear? So only HBr can add. So now HBr, for HBr we have two facilities available. Either we can add it directly, or we can add it in a reverse manner. Reverse means anti-Markovnikov addition. This is known as peroxide effect. It is also known as Kharash effect. And it is also known as anti-Markovnikov addition of HBr in the presence of peroxide. But not for HI, not for HF, not for HCl. Only. So they are going to add in the way in they used to get added. That is in always Markovnikov way. But only HBr can be added in a reverse manner, and that too in the presence of peroxide. So that's why it is known as peroxide effect. Okay, and it is also known as Kharash effect by the name of the scientist who studied this. Only for HBr, you should remember this warning, only for HBr. Okay, not for HCl. So now, suppose if we are having a compound and if we add HBr, normal HBr if we add, and if we add HBr in the presence of peroxide, what is going to happen? This is the peroxide, benzoyl peroxide. Okay. So what will be the products? Can you tell me IUPAC name of the products quickly? I hope everybody is trying to understand what I am saying. The statement, is it clear?
Yes, sir.
So this is simple addition of HBr on the left hand side. This is Markovnikov rule. That is Markovnikov addition. And this is going to proceed in a normal way. Rich gets richer. So where the H plus is going to come in, you can write it like this also. H plus is going to come in where you have more hydrogens. That is on CH2. Okay. And where the Br is going to come in, Br is not hydrogen, so it is going to come to the carbon, get attached to the carbon where there are less hydrogen, because Br is not hydrogen. Okay. So here you will put H, and here you are going to put Br. Got it? H, either you can write it or you can skip it. Okay. So this is Markovnikov. But in the presence of peroxide, the addition of HBr is reversed. Only for HBr it is reversed. So now the rich will become poor and poor will become rich. Okay, because it is anti-Markovnikov addition. So H plus is not going to come and get attached to CH2. Instead, it is going to come and attach to the carbon, this carbon which has less hydrogen. And you are going to have Br outside. So very, very important. Avyaz, Ibrahim, Jesslyn, Zainab, is it clear or not?
Yes, it's clear.
Jesslyn, clear? Okay. So only with HBr it is there. Now we move on to, because why it doesn't happen, sometimes a question come, theoretical questions come, that why HF and HCl do not give this anti-Markovnikov addition. So for them the reason is their bond is too strong. Because of the high strength of the bond, they do not undergo addition in anti-Markovnikov way in the presence of peroxide. So peroxide is not going to will not be able to break their bond. HF and HCl have strong bonds, and that's why they do not give anti-Markovnikov addition. HI, the bond is weaker, but I is very stable, so it doesn't add it successfully in anti-Markovnikov way. If they ask you, then you can say it. Okay. Otherwise, let it continue. But you need to remember. Yes. Next, let's move on to the preparation of alkyl halide from alcohol. Preparation of RX from ROH. So there are various methods. So we have completed the preparation of alkyl halide from alkanes by photohalogenation, from alkene by addition of HX, HCl, HBr, HI or HF. But HBr actually you were having more than one option. HBr you can add in a separate way also, right? In the presence of peroxide. Got it? So that you need to understand. Alcohol, there are various methods. Alcohol, and all of these methods, first of all, I will give you warning. These methods are applicable for aliphatic alcohol, not applicable for these methods which I am going to discuss. Not applicable for aromatic alcohols. Okay, there are a lot of questions in NCERT also, in text problem. They are asked in everywhere, all the examinations. Not applicable for phenol. So what are the methods? Preparation of RCl from ROH by using SOCl2, which is thionyl chloride. This process, so thionyl, if you treat alcohol with SOCl2, thionyl chloride, you are going to get you are going to observe that the alcohol OH group is converted to Cl. Okay, this is known as Darzon's chlorination, Darzon's reaction. At name, if you don't remember, not a problem, but you need to remember the reaction because it is the reaction which can give the best yield of alkyl chloride. So how it is carried out? Suppose if you take alcohol, this is the general formula of alcohol. R is any alkyl group. You treat it with SOCl2. What are the products which you get? You take pyridine also. What are the products you are going to get? You are going to get RCl, HCl, and SO2. SO2 is a gas, HCl is also a gas. So the byproducts are gaseous. They escape automatically and you get pure RCl. They can escape. So pure RCl with the best yield. So that is why preparation of chloride from alcohol using SOCl2 is considered to be the best method. Why it is considered to be the best method? Because the byproducts HCl and SO2 can remove on their own by heating their gases, they escape out. Is it clear? How you are going to remember the trick? The trick is like this: ROH. Got it? This is alcohol. Haloalkenes chloride is like this. Just write them side by side. Combine this Cl with R. Combine with this Cl on the other side with H. And combine this S with O. So this you will get RCl. This becomes SO2. And this becomes HCl. Is it clear?
Yes, sir.
Best method because the byproducts can be separated very easily and you don't have to separate them. Otherwise, what happens if you are getting a mixture of products? In order to get the product which you want, you need to separate. Separation causes yield loss. Why pyridine is used? Pyridine sometimes it is used to absorb HCl. Okay, it may be written like this also, minus HCl, because pyridine is a base, it can remove HCl. Okay, this is one of the method. How RCl is pure substance? Because this escape out, because it is gases. SO2 is a gas, so you don't have to remove it. It automatically gets into the atmosphere. HCl is also a gas. Normally, you may be wondering that we see HCl in lab in the bottle, how it is a gas. Okay, actually that is the aqueous solution of HCl. So, but if you heat it, it forms a gas. It's come in the gaseous form and it escape. So this will get removed. Okay, you will get this is removed. This is removed. You are left with what? In the reaction flask, only with your product, and that's what you want. Okay, you are preparing what? Alkyl halide. And if you are preparing alkyl halide, you don't want any other product to remain. Got it? Is it clear or not?
Yes, sir.
So This I hope is clear that why you get a pure form of RCl, because whatever the is being formed along with it escapes out by heating. Okay, so this is one of the method. Another method is by using HX, ROH, preparation of RCl from ROH. Preparation of RX from, we are all looking at the methods from alcohol. So preparation of alkyl halide from alcohol by treating it with HX. By reacting it with HX. What is HX? HF, HCl, HBr or HF. Why HX is used? That's the question. So first I will write the general representation. Then I will give you the idea. Suppose this is my alcohol. Got it? Is that clear?
Yes, sir.
Yes, sir.
And if I take sodium chloride, the reaction will not happen. Sodium chloride is just the salt, common salt which we have. No reaction will happen. I need to take HCl. Then the reaction can happen. Because this H plus combines with the OH and convert it to, this is what, water. Water can come out very easily because it is a stable compound and this R and Cl get connected. Are you getting my point or not?
Yes, sir.
So in whole organic chemistry, Abhyas, Ibrahim, Jesslyn and Janab, remember that wherever you are trying to remove the alcohol, OH group, use acidic medium. Why acid? Why H plus is required to remove OH group? Because the OH group along with the H plus, it can come out easily as H2O. Is that clear or not?
Yes, sir.
You may take catalyst also ZnCl2. And this HCl and ZnCl2, sometimes this is the catalyst. It is known as HCl and ZnCl2. Is known as Lucas reagent. Is that clear to everyone? But
Yes,
you can not only prepare chlorides, you can prepare bromides, you can prepare iodides. What I need to take, suppose if I want you to prepare CH3 from CH3 CH2OH, if I ask you to convert it to ethyl chloride, what you are going to take?
HCl,
Yeah, yeah, and
ZnCl2.
or SOCl2. Now we have two options for Cl. Either you can take HCl or you can take SOCl2 also. Got it? SOCl2 was one of the best ones. Okay. HCl you can use ZnCl to also catalyst to increase the speed of the reaction. Or if I ask you to convert it to CH3 CH2 Br bromoethane, Ibrahim, what I need to take?
CH3 CH2 Br plus HBr.
HBr. Okay, very good. HBr, if it is not available in the lab, you can prepare it. Normally these acids are volatile, so sometimes they are not kept in the form of acid. You can take the salt NaBr NH2SO. What does this mean? NaBr and H2SO. I wanted HBr, but why am I telling that instead of HBr you can use this also? Why?
So because end of the day we will get HBr. Yeah.
Yeah, we will get HBr. So this
With
HBr,
this
if it is not available, you can use these two things to mix them together and get the HBr. This is known as in situ preparation. Okay, this is a latent phase. In situ. Means something is not available, you mix two things and prepare that HBr. Okay, so how the HBr is going to come up? So NaBr is there, H2SO4 already has H plus, so you are going to get HBr and Na2SO. Is that clear? So either if HBr is given, the question is straightforward, or if HBr is not given, then also we can use the salt, bromide salt along with the acid. That again will give HBr. Okay. Suppose if I want Zainab to prepare ethyl iodide. So what I need in this place?
HI.
Which one?
HI.
Yeah, exactly. HI you can take. So this is the direct straightforward answer. That is correct. H plus I need because that H plus HI from H plus from HI and the OH they will combine, and that OH breaks out as water, and I is going to come in its place. Okay, and Avyas, if HI is not available in the lab, then what's the solution? How can I get this HI? Indirectly I can get it. I can take the salts NaI or Ki I can take. That has I minus. And I need H plus also. What? I can take some acid, but don't take HCl. Okay. Got it? Because if you are going to take HCl, how that HCl Cl is also going to get attached? Because we want purely the I minus to get attached. Okay. So there are two options, H2SO4 or H3PO. And as this is also a very famous question, NCERT has told that don't take H2SO4. Are you getting my point? Because though the HI will form, but HI is highly reactive acid and H2SO4. With H2SO4, it is going to change to I2. So don't use H2SO4. You can use H3PO4 concentrated, which is the best option for if you want to get HI. This is the fact which you need to remember. It is given in the in-text problem also. Got the point? Are you getting your point or not? Everybody.
Yes.
So just we will try to look at where it is given. So this is your NCRT. This to be used if HBR is not available. Okay. Can you see this? Can everybody see this clearly?
Yes.
So if I want HI and if I want alkyl iodide with alcohol, I can take acid H2SO4. But in the case of HI, why H2SO4 should be avoided? Instead of H2SO4, H3PO4 must be taken. Why? What?
Highly reactive.
Highly reactive, it is oxidizing acid. And HI which is formed, HI will form. But HI is a very good reducing agent also. It gives H plus, okay, and I. So it will get oxidized too if you use concentrated H2SO4, which is also an oxidizing acid. So whole HI will get spoiled and it will get oxidized to I2. That you need to write and remember. This very simple thing, many of the students preparing for JEE Advanced also, I keep them informed again and again, they forget. There are some very small things which are there in the NCRT, but everybody forget them. Okay, so will you be able to write the reason correctly? Avyaz and Ibrahim, tell me quickly. What's the reason? Why I shouldn't go for concentrated H2SO4 in case of HI? You will say that H2SO4 is an oxidizing acid. It will destroy the HI and convert it into I2. If you have I2, now you are not going to see the reaction happening because you need H plus. Okay. Is it clear? Has everybody written it?
Yes, sir.
Okay. Very important. Very important, and you can ask all your friends. Okay, they will make a mistake. Some basic things where everybody goes wrong. Okay. So this I hope is clear. So let's do these problems. What I am going to write in this case, just quickly tell me. Who is going to tell me the answer? Avyas, are you there?
Yes, sir.
Yeah. So what should I write? This is an alcohol. I'm reacting it with SOCl. What should I write? SOCl to what it? How it reacts? What will form? You are going to get alkyl halide. Whatever the alkyl group you have taken, that you are going to keep same, R. So here the R group is cyclohexyl, okay, fluorocyclohexane. Is that clear to everybody?
Yes, sir.
Right? And what about this one? If you react it with HCl, there are two OH groups. Just at the starting of this type of reaction, I told you one thing, that these reactions are for the preparation of alkyl halide. Yes, Janab, H2 will also be there, but we don't write it. If it is asked to write the complete equation, then we should mention H2 also. Otherwise, if they are asking the main product of the reaction, then you are right, that we are more interested in the organic product. Okay.
Yes.
If you are asked to write the complete equation, then you should write the H2 also. Okay. Right. So there are two types of alcohol. There is one aliphatic alcohol and one aromatic alcohol. This is benzylic aliphatic. Aliphatic means alkyl group. Okay, connected to normal carbon. And aryl is the benzene. Okay, aromatic group. So where the HCl is going to react, is the HCl going to react on both the OH, or is it going to react with only with the one OH? That is very important. Ibrahim and Avyas, tell me. Yeah, quickly tell me. What's the, where should we react?
So could you repeat the question?
Which OH need to be replaced by Cl? Both of them or any one of them?
So any one of them.
Which one?
Any one of them, but one will be a major
CH2.
and one will be a minor, I guess. Yeah, we get one major and one minor product.
Yeah, Ibrahim. One major and one minor. Actually,
Yeah.
this reaction, this OH is very difficult to remove, because this double bond and this pi electrons are undergoing resonance. Okay, so this OH, the aromatic OH, will not show this reaction. This is undergoing resonance with the lone pair. I will explain it in detail how that is happening. It is in the upcoming topics. So as of now, you can just write it that if the OH is directly connected to the benzene, it is having a partial double bond character due to resonance. Between the benzene and oxygen OH group. Okay, PHOH due to resonance. So is it easy to break this OH group now? Tell me. Is it easy to break this OH group or difficult to break this OH group if it is connected by partial double bond? Mean there is one bond and there is one more additional bond which is being formed because of the bonding of the lone pair and pi electrons. Got the point, Zainab and Jaslin?
Yes, sir.
Yes, sir.
So will it be replaced easily, or will it be replaced by with difficulty, or will it not be replaced? It will not be replaced. Okay, that's why in the beginning only I told you, look, that all these reactions which we are going to discuss, of alcohols, look what I have written. These reactions are not applicable for aromatic alcohol. Got it? So this OH is not going to be replaced. Only you are going to replace the OH which is connected outside the benzene, not directly to the benzene. So CH2Cl and OH, this is left intact. You have not removed it, okay? And plus water. Got it? Will not react. This is the reason which you need to write. I will explain it in detail in the upcoming topics. Is that clear?
Yes, sir.
Okay, good. So now reaction with HX can lead to the formation of alkyl halide from alcohol. But the alcohol, the OH group should be connected to an alkyl group. The OH group should not be on the benzene. Right? That you must remember. Okay. So suppose if we are having this kind of molecule, how many Cl are going to come in this molecule, get attached to this molecule? Ibrahim, are you getting the question?
Yes, sir. Yes, sir. Yes, sir. It's not.
So-
It won't be the bottom one because of the double bond. So
Yeah, it will not react.
yeah, it won't be the bottom one. So it has to be the leftmost.
Yeah. So this is normal OH connected to the carbon outside benzene, not directly on the benzene. Zainab, Jasleen, are you getting my point?
Yes, sir.
So this OH will get replaced by Cl, water will come out easily and the Cl will come in place of OH. This is one thing. This OH will not be replaced because it is connected to benzene and there is a bonding, extra bond being formed between the lone pair and the double pair. And there is one more Cl which can come in. Zainab, what is the reason and what type of reaction is it? That we have seen yesterday in yesterday's class. This is alkene and HCl can undergo addition of the alkenes can undergo addition of HCl in a Markovnikov way. So H plus is going to come here because you have CH2 and the Cl is going to come in the middle. Are you getting my point, everybody? So two types of reaction. One, yesterday's reaction on the Markovnikov addition on double bond, and now today's reaction, the replacement of OH by Cl. Got it?
Yes, sir.
So how many chlorine are going to come in? 2. But that phenol will not react. Okay, the phenol means that one which is connected to phenyl. Now let's move on to the other methods. Preparation of alkyl halide from alcohols. We are discussing from the alcohol by using phosphorus halides. What the phosphorus halides, what kind of phosphorus halides will be? Okay. Phosphorus, either you can take red phosphorus, or phosphorus if it is not written, just phosphorus, okay, or red phosphorus and chlorine, okay. This is, or you can take PCl3, okay. So P plus X2 and PX3 are one and the same thing. Got it? So either you can take red phosphorus plus Br2, or you can take PBr3, because if you are going to take, they are going to react and they are going to form. Or you can take red phosphorus, red because white is very reactive, Ni2, Pi3. Got it? Is it clear or not?
Yes, sir.
Got it? Pi3, or you can use PCl3, or you can use, there is one more pentahalide, but pentahalide, the Cl can form very easily. So you can use PCl3, and there is PCl5 also. So these many options are there for you. Getting our point? Got it? So what happens if you treat such either PX3, it is a general way of writing PCl3, Pi3, PBr3, or PCl5. Okay. So whatever these reagents are you take on alcohol, you are going to do just one thing. Okay. What is that one thing? You are going to replace the OH by halogen. Halogen, you will look into the phosphorus halide, which halogen is taken. Okay. So what we need to do, PX3 or PX5 or red phosphorus plus X2. Got it? This and this are same. Is it clear? This is just the overall reaction, not the details. Details, I am getting to the details. Ibrahim, Jasleen and Zainab. Is that clear? The basic idea,
Yes,
the
sir.
basic purpose of taking the halide, phosphorus halides, okay? But how it is going to happen, that I'm going to explain. And what is the balanced equation? Because sometimes they ask you to write the complete equation. Suppose if I have taken CH3OH, Ibrahim, okay? So if I treat it with PBr3, what I'm going to get? Br will come in place of OH in H3PO3. But how to remember such a complex formula, or it can be confusing. So very simple. What you are going to do is, got it? Write the 3 molecules of alcohol, because you are going to put 3 OH on PBr. Side by side you can write. remove this and connect each Br with the alkyl group. Ibrahim, are you getting how to draw the product?
Yes, sir. Yes, sir.
So you are actually having 3 moles of alkyl halide reacting being formed from 3 moles of. You can just write it as 3. This is the overall balance equation, Zena. Okay. And P with 3 OH groups, that is S3P. This reaction is not applicable on aromatic alcohol, which is connected directly to the benzene. That is very important. Got it? Suppose if I give you CS3, OH and PCl5. This is a different reagent. Okay, what you are going to do? You are going to make, because it is Cl, you are going to put the Cl. So even if you forget the reaction, you can just, by intuition, you can write and think of the product. What will be the products that I am going to explain? POCl3 and HCl. For PCl5, what's the trick? This trick is going to be applicable on all the next upcoming chapters. PCl5, the trick is you write the alcohol just like we adopted the same trick for SOCl2. You write PCl3, H can connect with the Cl, R can connect with the Cl. Just write it like this, and you will have the products, byproducts, POCl3 and HCl. But this is not a very as good as SOCl2, because SOCl2 there you were getting SO2. SO2 was volatile and that it was a gas. So there it was removing. POCl3 will not come out so easily. Is it clear? So all these reactions they are applicable on aliphatic alcohols. They are not applicable on phenols, where the OH group is directly linked to the benzene. Okay. Is it clear to everybody? Any doubts on this? Ibrahim, Jasleen, Zainab? How to draw the product with PCl3 or PBr3 and with PCl5?
Yes, sir.
Okay. With Br3, you are going to write 3 alcohol. Just collect the 3 OH and phosphorus together, put it on all the 3 OH on the phosphorus and 3 Br, each one of them on the halide. Ibrahim, with PCl5, you are going to cut the alcohol in 3 pieces. And PCl5 also you are going to cut it in 3 pieces. Okay, one Cl on H, another Cl on ethyl, and
Yes, sir. Yes, sir.
PCl3 on O. Okay, that's how you are going to do it. So this is your method for from alcohols. Okay. HBr peroxide, I told you today what is going to be the product, so you can try this one. Okay, very simple. This we completed. Now, and suppose if we are putting HX, we have seen that H and X are going to come in and they are going to add in Markovnikov fashion. But if you are reacting with, instead of HBr, if you react with Br2, then you are having, then it is not a matter of concern whether you want a Markovnikov or anti-Markovnikov, because this is very simple. And this is the two Br atoms get connected to adjacent carbon, and you are going to get a vicinal dibromide. This reaction holds a special significance in class 11th. If you have seen, can you tell me? It is used as a laboratory test. This is the addition of Br2. Laboratory test for what? Any idea? Suppose, Ibrahim, I give you a test tube which contains some organic compound. And if I ask you to tell me whether this organic compound contain double bond or not.
Yes.
So that organic compound, what you are going to do? Are the double bond visible
So
by the naked eyes?
no, we'll add bromine. We'll add
we
bromine, and if it
we
turns
will add
into
bromine.
bromine water, yeah.
Yeah, bromine water, addition of bromine water. Okay, because bromine is a liquid, and that is, it has color also, reddish brown color.
Yes, we can.
Reddish brown color. So if there is a double bond, the bromine is going to get added to the double bond, and you are going to have the two Br atom on the adjacent carbon being added onto the adjacent carbon. Got it?
Yes, sir. Yes.
Next is, what is given is halogen exchange reaction. What this is basically? Halogen exchange means already you are having one halogen. Till now, whatever the reactions we have seen, we were bringing in the halogen in place of H by photochlorination or photohalogenation in the presence of light. Today, yesterday, in the last class also, we have seen that how to bring the halogen in place of double bond. You are going to put the HX. And this just now, today, in today's class, we are seeing how to replace the OH group by halogen. Okay. We have halogen exchange reactions also, and they are Finkelstein and Schwarz. So it is used to prepare iodoalkanes from alkyl chlorides or bromides by replacing their Cl or Br atoms. Iodoalkane. Got it? And how, which reagent do you use? You use NaI or Ki mixed into acetone. Schwarz reaction is used for the preparation of alkyl chlorides. From alkyl chloride or bromide. So these are halogen exchange because already you are having a halogen atom and you are replacing it with iodine or fluorine. So AgF is the main reagent and Ki acetone or NaI acetone. So this is a very simple reaction. This is I minus. This is going to come and join in and it will push out the halogen which is Cl minus or Br minus. And in acetone they are less soluble, so they form a precipitate. So NaCl and NaBr are thus precipitated in acetone. This is the key point. Why you use acetone? And so the NaCl, NaBr are more ionic and they doesn't get dissolved into it and they form precipitate. So thus this helps the reaction to get completed and move in the forward direction. Is it clear? Just remember this. Okay. Or if you want to put fluoride, then also you can easily do it. How you are going to get the fluoride? Okay. The fluoride you can use AgF. This is the most common. Why AgF is most common? Because AgBr is going to form the precipitate. If it is going to form the precipitate, the Br minus will not be able to come and join in again to the carbon bearing the fluorine. Okay, so the whole reaction will move in the forward direction. Though you can use Hg2F2, COF2 and SbF3 also, but this is the best reagent AgF because AgF is soluble and AgBr, AgCl are insoluble. Is it clear? So in the next class, we will see the preparation of haloalkenes, haloarenes, aryl halides. Okay, so that also is very important. By that time, you can complete all the in-text problem. This one. Okay, we discussed a lot of the things today, yesterday. Okay, this one. This we discussed. Okay, a lot of things we discussed. You can complete a lot of reactions now. Okay, I hope everybody is getting. In case of any problem, do tell me, do stop me in the class. Okay, and you can also start your back exercise. Okay, some of the preparation method in the back exercise actually they can be easily done. Okay, so we will cover it on the next one. So let me end today's class. Just revise it from your NCERT. In the next class, we are going to start with the preparation of aromatic halides. Got it? So I hope this is clear. Today's class, I will give you the assignment. Do that basic questions related to what we discussed. So bye bye. Take care. Good night.
Thank you, sir. Goodbye.